Well, good morning to everyone in Dublin. I'm so sorry that I can't be there in person to see everyone. We had a long scheduled family reunion that's scheduled right concurrently with the meeting, so it was something I couldn't miss. So unfortunately, I just wasn't able to attend the meeting. But I do want to thank the organizing committee very much for including this invitation for us to talk about our current work. And I will just show you my screen now. Okay, the title of my talk today is Threat versus Deprivation in Mother's Childhood, Differential Relations to Infant Brain Volumes and Cortisol Responses. So we're all familiar, I know a lot about the intergenerational cascade associated with adverse childhood experiences. Importantly, this is an intergenerational cascade where early adverse life experiences of the parent seem to also be affecting the physiological and neurobiological adaptations to stress in particular in the offspring generation. This involves altered trajectories of stress hormone regulation in infants and children, altered trajectories of brain development, very importantly, and the emergence of physical and psychiatric disorders. The study that we're currently involved in, the Mother-Infant Neurobiological Development Study, the MIND study, which I've done with a great group of collaborators, is focused on assessing the effects of maternal childhood maltreatment on infant brain and behavior over the first 2 years of life. This just gives you a schematic. We have a small prenatal sample, and then the bulk of the sample was collected starting at 4 months, a sample of 181 families, and then again at 15 months. But today I'm going to be focusing only on the 4 months data. We have not yet delved into the 15 months data. And I'm not going to do a lot of methods discussion in this talk, so please feel free to email me for the papers if you would like to get more methodological details. Importantly, the sample was stratified for maternal childhood maltreatment. So mothers were screened so that 53% of mothers in the sample had experienced at least one form of childhood maltreatment. And we screened them on the Adverse Childhood Experiences Questionnaire, the ACE questionnaire, which we're all hearing a lot about. The 10-item ACE assesses, among other things, 5 types of childhood maltreatment. And in the talk today, we're only focusing on the 5 types of childhood maltreatment on the ACE, not on some of the other general family maladaptation questions in the ACE. So we were looking at emotional, physical, and sexual abuse as part of the abuse measure, and emotional and physical neglect as part of the neglect measure. And then all of those together as our overall maltreatment measure. We also used a much more extensive assessment of the mother's childhood maltreatment, the MACE scale developed by Marty Teicher, one of our collaborators. This is a much more detailed instrument. It divides abuse into verbal abuse, nonverbal, emotional abuse, physical abuse, and sexual abuse, as well as emotional neglect and physical neglect. And we used both instruments, and we're getting really interchangeable results from the 2 instruments. So they're used somewhat interchangeably in the results that follow. The major focus of the study, as you might imagine, is the effects of maternal adversity, in particular on the infant threat detection network, including the HPA axis and the amygdala. The amygdala, of course, is very important in stress pathways because it's the fear center in the brain that is sort of primary in threat detection. It's also part of the larger limbic system for emotion response and regulation, and particularly including the hippocampus, which is our memory center and helps us to remember these various threatening situations and code them for the relevance for future behavior. And then there are extensive connections to many other brain regions, including the HPA axis, which is a very important feedback loop for the amygdala and hippocampus. The MRI sample was smaller than our larger overall sample, as you can imagine, because it's very difficult to get infants and toddlers into an MRI facility, get them to fall asleep, and do an unsedated scan. So we had 57 infants. This just gives you a sense of what the equipment looks like, who came in at night, fell asleep, and got a clean scan and between 4 and 24 months of age. It's 1 for over the age range. Also notably, there were exclusion criteria so that we did not include any infants less than 36 weeks gestation, less than 25 grams birth weight, or having any evidence of congenital disorder or birth defect, given our interest in looking at brain development. So the data acquisition and processing was done primarily at Boston Children's Hospital. And we looked at a variety of brain regions. The ones we're going to focus on today are brain gray matter volume to some extent, but particularly amygdala volume and also to some extent hippocampal volume. And very importantly, the 57 infants who completed the MRI did not differ from the remaining infants in the sample. They didn't differ on demographic characteristics, so age, family income, et cetera, minority status, mother's education. And they also didn't differ on the severity of the mother's childhood maltreatment. Very important, since that was a major variable in the study. Now, we're focusing in on the human amygdala in part, and particularly on brain development, because there's a very rapid increase in human amygdala volume during the first 2 years after birth. You can see in this graphic that this is first 50 months of life, so the first 4 years of life, and you can see that this growth just takes off over these early months of life, and also on the left amygdala and also on the right amygdala. In addition, we find that overall gray matter volume, the brain cell bodies themselves, reach 80% of adult volume by 2 years of age. This is sort of, I still find this a stunning number. So clearly, so much is happening after 2 years of age. Rather than generating more cell volume, what's happening is pruning and myelinization of the connections between brain cells. So clearly this period of very rapid growth probably signals an experienced expectant sensitivity to environmental inputs. We think the brain is much more sensitive during these periods of rapid growth. And this sensitivity is also thought to be very adaptive for the infant, enabling the infant to adapt quickly to the contingencies in one's environment as the brain encounters the different aspects of environmental care and response. Rodent models have told us a lot about the impact of stress on the amygdala. The amygdala is particularly vulnerable to stress because it has a very high density of stress hormone receptors. So receptors for glucocorticoids, which are basically cortisol hormones. Stress increases the dendritic arborization in the amygdala, so they're sending out more dendrites and leading to this enlarged amygdala volume. And then importantly, in rodents at least, these enlarged volumes seem to be resistant to change into adulthood, even after the removal of the stressor. We don't know yet whether that will apply to humans or not. And particularly in rodent models, the model of a stressor has been low maternal nurturance, or in Callie Barham's lab, she labels this maternal unpredictability. But basically inconsistent and inadequate responsiveness from the mother. This is associated with elevated amygdala activity, with decreased benzodiazepine receptors, or sort of the more calming receptors in the amygdala, and increased transcription of stress hormone RNA in the amygdala, so regulating cortisol. So there's another interesting finding in the rodent literature. So the primary model, this model of low maternal nurturance or unpredictability, is related to the HPA axis increase and to the amygdala volume increase. As I said, there's a huge volume of randomized controlled trials, as they can only do so elegantly with rodent models out there. documenting this model. It's another interesting aspect, though, that Regina Sullivan's lab has contributed to our understanding of this early stress period, and that is in rodent models that there seems to be a hypo-responsive period to aversive maternal behavior as opposed to low nurturance or unpredictability, lack of responsiveness. So in this model from Regina Sullivan's lab, maternal aversive behavior, and aversive behavior in this case is an electric shock that she pairs with maternal cues, such as maternal odor. So quite an aversive stimulus. The HPA axis does not respond to this stimulus until after weaning. I'm put 18 months here referring to human infancy and not to rodent infancy, after weaning in the rodent studies, and also delayed amygdala activity as well until after weaning in the rodent studies. So very clear models and lots of replication in the rodent literature of what we might expect in relation to low maternal nurturance and also maternal aversive behavior. However, the human literature presents an almost opposite picture, or a very different picture, of how stress might affect neurodevelopment. So in particular, the human literature, and especially the elegant work that's being done in Katie McLaughlin's lab, differentiates between the effects of threat, defined as harsh treatment or abuse, and the effects of deprivation, defined as neglect or caregiver disengagement. And these have been looked at extensively in older children and adults. And the model that emerges from that is, as we see, somewhat different. So deprivation, which would be the neglect disengagement or low maternal nurturance dimension, is seen in older children and adults to have no effect on the HPA axis and no effect on the amygdala. Instead, early neglect, childhood neglect, is related to lower gray matter volume. And Katie's lab has documented this in a series of papers. The human models of threat among older children, and threat then defined as the threat of attack or injury, sort of the traditional definition of threat, harsh treatment or abuse, leads to increased HPA axis response and reduced right amygdala volume. So quite different models emerging from rodent literatures on infants and human literature on older children and adults. So the critical question we've been facing is which of these models might apply to human infancy? So the first set of analyses that we did assessed the relation between mother's childhood maltreatment in general and the regulation of infant cortisol. So does the mother's childhood maltreatment have an intergenerational impact on infant cortisol? And the procedure that we used to assess infant cortisol was the still face paradigm, which I'm sure many of you are familiar with. This just gives you a schematic of that paradigm. This was at 4 months infant age. So you see on lab entry, if the first cortisol is assessed, the mother and infant then engage in 3 minutes of face-to-face interaction. The mother then stills her face for 2 minutes, which is a mild stressor for the infant, at least in terms of behavioral manifestations of distress and negative affect. The reunion episode, then the mother interacts with the infant normally. Again, we did a 5-minute reunion period. And then second cortisol sample comes 20 minutes after the onset of the stressor. And the third cortisol sample 40 minutes after the onset of the reactivity to the stressor and recovery. As you saw, saliva is collected over 3 time points, so we can look at the way that the cortisol responds over those time points. This is also afternoon collection, which is important because of the steep cortisol slope over the morning. And we also did the procedure in the home to avoid having the infant come in a car ride that often puts the infant to sleep, and then exposure to a strange lab and a strange set of people. So what did we find in terms of the relation between overall maltreatment and infant cortisol regulation? Well, it turns out that there were a number of effects that differentiated infants whose mothers had low maltreatment from infants whose mothers had high maltreatment. We're using a continuous severity of maltreatment measure. So this was sort of the highs and the lows of that continuum. First thing is that the mother and infant cortisol were less highly correlated in the high maltreatment group, as you can see in this graph. So the mothers and infants are both declining in cortisol over the course of the procedure. You do not see a reactivity and recovery. A picture here, you see both mother and infant, and particularly let's focus on the infants here, declining to 20 minutes after the still face and still being calm after that. In the high maltreatment group, you see a very different infant picture. The infants start out relatively high. They remain high right over the course of the procedure. So less correlation between mother and infant, more absolute difference between the values of the infant's cortisol and the mother's cortisol. As you can see here, quite a gulf. Mothers are, if anything, maybe somewhat blunted. Infants are highly stressed by this. And then finally, we did actor-partner influence models, looking at how the infant's cortisol affects the mother's cortisol and vice versa. And what we found was that in the low maltreatment group, the infant's cortisol levels had an influence on the mother's cortisol level at the next assessment point. Whereas in the high maltreatment group, the infant's cortisol did not influence the mother's cortisol. So mothers with lower maltreatment were more responsive to the infant's stress level and mirrored that more in their own stress level, whereas in the high maltreatment group, this influence from infant to mother did not occur. And you can sort of think about the importance of early regulation of stress between mother and infant is a vital process, and it seems to be not occurring in the same way in the high maltreatment group. So we're seeing an effect here of maltreatment, mother's maltreatment in childhood on the infant's cortisol regulation. The next question is, does cortisol regulation affect infant brain development? This is a question that has not been addressed yet in the human infant literature. So this graphs for you the cortisol level. This is infant total cortisol level here. And this is the relation between cortisol and the trajectory over the still face procedure among infants with larger amygdala volumes. And as you can see, the infants with larger amygdala volumes are those who have higher port levels over the course of the procedure. As we just saw in the other slide, was related to the mother's childhood maltreatment. Infants with smaller amygdala volumes are showing this decrease, as we saw for the infants whose mothers had lower maltreatment. So we get a similar pattern in the MRI sample, which is of course much smaller, and the MRI sample is able to tell us that those cortisol levels are also having an impact on infant amygdala volumes, or at least are associated with. I shouldn't slip into causal language. And this just gives you a different view of the same data. This is just the overall total cortisol output, not plotted over the 3 time points. And you see the slope here as cortisol goes up, infant amygdala volume goes up, and also it shows you the hippocampal volume results, which are very similar. So as cortisol goes up, infant hippocampal volume goes up. And note that these brain volumes were collected from 4 to 24 months of age, while the port levels were only at 4 months. So there's something powerful about the 4-month port levels that seems to keep reverberating across the first 2 years of life. Now, they continue to interact with their mothers and their environments, and many more things are happening. So there can be much more going on than just the infant's 4-month port level, of course, but it's certainly an important indicator of brain development. So this is an important result because it's the first study we know of to examine infant limbic volumes in relation to cortisol levels in infancy. And the results replicate the clear and repeated connection found between elevated stress hormones and increased amygdala volume that's been repeated in control rodent studies. So our human infant data seem to be following the well-replicated pattern in rodent primate studies. So the next question is, are higher infant cortisol levels differentially associated with the mother's history of abuse versus neglect? We looked at overall maltreatment in the earlier slide, but there may be differential prediction of abuse and neglect. So the human threat deprivation model has, as we noted, very different predictions about this. Higher stress hormone levels should be associated with abuse or harsh treatment, either in the mother's history or in current interaction. The rodent literature instead would say that higher stress hormone levels would be associated with neglect and low maternal nurturance. So quite different correlates of higher stress hormone levels would be predicted by the two models. So this is the maternal childhood abuse severity in this model. See that here. And it was not significant at all in relation to this pathway to infant cortisol output and then on to infant amygdala volume. So no relation to infant cord output between the mother's childhood abuse severity, and also no indirect relation. We also looked at potential mediation, which you wouldn't expect given that there's not much going on here. But again, the indirect pathway was also to infant amygdala volume through cord was not significant. So we're not getting any relation between the mother's abuse severity and her infant's cortisol level at this early point in the first year. Very different picture with maternal childhood neglect. So we see here that we're getting a significant effect of the mother's childhood neglect severity on her infant's cortisol output at 4 months of age. And we already know that cortisol output is a correlate of the infant's increased amygdala volume. In addition, we get a significant mediation effect such that the mother's childhood neglect severity is further affecting the infant's amygdala volume indirectly through this pathway. So direct effect on cortisol and an indirect effect on the infant's eventual increased amygdala volume. So what are the implications here? Clearly, these intergenerational results are fitting the rodent model so far better than the human model derived from older children and adults. So the mother's intergenerational neglect associated with increased HPA axis and increased amygdala volume. However, we also are very interested in whether postnatal maternal behavior is contributing to these effects. That's certainly one potential mediating mechanism that might be carrying forward the effects of neglect on later infant outcomes at 4 months. And just to remind you, there are sort of two different kinds of caregiving that would be of interest to us based on the rodent models. So we would expect from rodent models that low maternal nurturance or unpredictability would lead to HPA axis increase and amygdala volume increase. But there may be a hyporesponsive period to harsh and negative caregiving. So maternal aversive behavior may not, in fact, be associated with increased HPA axis activity or increased amygdala activity. We don't know how to translate rodent weaning exactly into when in human infancy we might see this delayed effect of maternal aversive behavior. We're guessing something like 18 months here. So we looked at maternal disrupted interaction coded with our ambience coding system in the reunion episode. That was a 5-minute episode when they returned to normal face-to-face interaction in the still face paradigm at 4 months. The coding system includes just an overall rating for disrupted maternal interaction, including all the areas of disruption that we look at in the system. But there are also 5 specific rating scales which try to capture some of the less responsive and more intrusive dimensions that are a part of a disrupted picture or different disrupted pictures. So the affective communication error scale, these are sort of miscommunications, not responding to signals or responding inappropriately. This is a pretty general feature of disrupted interaction, whether it's less responsive interaction or more harsh interaction. Then the negative intrusive behavior is certainly the sort of key aspect of more harsh and aversive behavior. Role confusion by the parent, which means drawing attention to the self when the baby is in need, tends to correlate with negative intrusive behavior often, and to feel like an intrusion on the infant, because it's also trying to get something from the infant that the infant is not signaling they would like to give. So these are some of the more negative intrusive aspects of interactions captured on the ambience. And then disorientation and withdrawal seem to capture more emotionally disconnected or less responsive interactions. Disorientation characterized by more odd, apprehensive affect and frenetic behavior, and withdrawal characterized more by sort of physically removing oneself, not talking to the baby, moving away from the baby physically. So we looked at these aspects of interaction, first in relation to the infant stress hormone level. This is the overall level of maternal disrupted interaction. It is significant in relation to infant elevated cortisol in the SFP at 4 months. But we also wanted to look separately at these different dimensions, because it's quite possible that harshness versus low nurturance would have different effects based both on actually the human models and the rodent models, although they would make different predictions about that. So as we disaggregated that overall measure, what we find, let's look first at the negative intrusive behaviors, because these are the most widely studied behaviors. If I'd had to bet, I would have bet that they would have been very important in relation to infant cortisol at 4 months of age. And we found, no relation to infant cortisol. Now, it's not that these are not being registered by the infant and that they're not important indicators of a difficult history in the mother. They're significantly associated with the mother's history of abuse in particular, and this replicates a lot of literature on harsh treatment and maternal childhood maltreatment. And also significantly associated with infant distress in the still-face procedure concurrently with the negative intrusive behavior. So it is being registered by the infant, but it does not trigger infant cortisol, which I find quite an interesting discrepancy. What does trigger infant cortisol is clearly and robustly so disorientation in the interaction between mother and infant. And this just gives you a graphic showing you, this is the scale for maternal disorientation. It actually goes to 7 points, but there wasn't anybody rated at 7, level of 7. So you see there seems to be an inflection point here after a scale point of 3. We then start to see elevated infant cortisol, and there are a number of families here, 22 families, 22 mothers who are showing these elevated levels, and presumably are part of the group of infants then who have elevated cortisol. And then the next question, of course, is this disorientation linked to enlarged infant amygdala volume or just to infant stress hormone levels? And if we look at this graphic, what we see is that maternal disorientation is indeed related to infant amygdala volume, though not directly, very much like the mother's history of neglect was not directly related. So maternal disorientation instead elevates infant cortisol output, just as the mother's history of neglect did. Infant cortisol output then is related to infant amygdala volume. And maternal disorientation also has a mediated indirect effect on infant amygdala volume through its relation with infant cortisol levels. So again, very important that part of this pathway to enlarged amygdala volumes in the first 2 years of life. Just to give you a little more sense of what these disoriented behaviors look like, we have 39 specific behaviors that we sort of check off under the maternal disorientation coding system and then give an overall rating from 1 to 7. So some of the behaviors are things like odd voices in interaction with the infant, these strained voices, high, tight voices, or ghostly whispers, just unexplained voice changes that go up and down as the mother talks, and you can't quite tune into why. Parents who shift rapidly from behavior to behavior. So at 4 months, the parent may sing one song and then sing another song and then shake the infant and then try something else and then laugh. And you don't get a sense of why the parent is making these quick shifts in behavior. They certainly don't seem to be in relation to infant cues. And then fearful or apprehensive postures or expression. There seems to be some kind of apprehension around the interaction with the infant that's evident in the mother's behavior. And then the overall feel of this from the coder notes is that these parents are emotionally disconnected from their infants. As you can see, this odd affect would be hard to connect to whether you're an infant or an adult. That the parents are awkward, uncomfortable, and quick to disengage. This mother doesn't seem to know her infant. So a definite sense that there's an emotional disconnection mediated in part by these odd affects and odd behaviors in the parent. And this makes sense when we think about the centrality of emotional communication in the first 2 years of life. The baby can't talk to us, of course, in words. So the exchange of mutually contingent affective signals is essential to caregiver-infant communication in early life. And so no accident probably interactions that effectively raise the infant cortisol with the odd disoriented behaviors that are blocking any kind of genuine affective communication between the mother and the infant. So overall, the implications of this last set of results is that infant cortisol levels and maternal caregiving behavior are both likely to be mechanisms that are important in these intergenerational transmission pathways and also in the early shaping of the infant brain. So it looks as though our results fairly closely follow the rodent models. Early low maternal nurturance or neglect being associated with increased HPA activity and enlarged amygdala volumes, and also no apparent effect of aversive maternal behavior. So negative intrusiveness is not related to increased cortisol or amygdala volume. The mother's history of abuse is not related to either, which we certainly would have expected. So these are somewhat unexpected results, although, as I say, very consistent with what we see in rodent models. Notably, of course, the rodent models are also being assessed in early infancy in the rodent's life. So very consistent, and they were both looking at what might be happening in infancy as opposed to later in life. So what about the threat deprivation model that's derived from the human literature? Where does that stand, and how might we integrate these two models? So just to review that model again quickly. So in a lot of the work coming from Katie McLaughlin's lab and her colleagues, deprivation would be predicted to have no effect on the stress response axis or the amygdala, but should lead to reduced gray matter volume. And then another set of cognitive effects that would go with reduced gray matter volume. Among older children and adults, we also find that threat of attack or injury is related to increased HPA axis responding, and that in turn is related to reduced right amygdala volume. Note that this is specific to the right amygdala, which has been repeated throughout the literature on psychopathology and stress. There's something about the right amygdala hemisphere that seems to be differentially responsive to aversive, abusive interaction. So we've already seen that increased infant cortisol to neglect rather than to abuse does not fit well with this framework. However, there are other aspects of our findings which do fit well to the threat deprivation model. So let me review those quickly, and then we'll try to integrate this, see what kind of model we need to account for all these findings. Sorry. So reduced gray matter. Reduced gray matter is, in fact, clearly related to the severity of maternal childhood neglect, just as the threat deprivation model would predict. and is not related, low gray matter volume is not related to the severity of the mother's history of abuse. This is interesting and important because this is the first finding differentiating intergenerational effects of neglect and abuse on gray matter volume. When we look at amygdala volume, we also find what's predicted by threat deprivation theory. So reduced right amygdala volume, but not left amygdala volume, is shown in relation to the severity of the mother's childhood abuse. This emerges after we control for the severity of maternal childhood neglect, which of course we've already seen is leading to increased volumes. But controlling for that effect of neglect, we find that in fact abuse is having this effect of decreasing amygdala volumes. However, as very importantly, this decrease only becomes evident after 18 months of age, so 548 days. So for some reason, this effect of the mother's abuse history on the amygdala is delayed. And we're going to sort of think about that going forward in terms of integrating these models. So we get this second indication that effects associated with the mother's childhood abuse, as well as with her current negative interaction with her infant, do not seem to be evident until later in the second year of life, or maybe even later than that. So how can we integrate the rodent and human models? And we propose that we might need to flip our current models on their head, essentially. That the period of infancy may need a reverse model compared to the models that we have for later childhood and adulthood. How would that model look? So fear and threat has been discussed predominantly in terms of the threat of attack. With fear of attack then provoking fight, flight, or freeze responses. We've all very familiar with this theory. People like Robert Sapolsky studying animals of all species has written books about this. However, arguably, if you think about human infancy, the most primary and potent threat in infancy is not attack by a predator, but neglect or abandonment by the caregiver. Abandonment, and I'm using that term very broadly, is inadequate care, in turn exposes the infant to a variety of threats to survival, including starvation and freezing, as well as exposure to predation. And in addition, differentiating between these two kinds of threats is important because they require very different adaptive responses. The standard model threat leads to fight, flight, or freeze does not fit at all with a threat associated with a lack of adequate care by your caregiver. So the neglect abandonment threat calls for a very different set of adaptive responses, and we see those adaptive responses again throughout the animal kingdom. The infant will call and contact seek toward the parent. They try to get close to the parent, they call, they cry, they get distressed. This is very clearly evident. So it looks as though if we can reconcile these models by a developmental salience model. And the developmental salience model would posit that there's a developmental sequence in the elicitors of a stress response. That in infancy, the primary elicitor of a stress response may be the threat of lack of care. And that may be what's differentially salient to the infant cortisol system and the infant limbic system, the amygdala hippocampal network, in the first 2 years of life, contrary to the prevalent theory. Threat of attack or injury may become more salient after the period of initial attachment formation in humans. That would be, 18 months to 2 years roughly, and then gradually increase over the preschool period. This would be consistent with Sullivan's rodent findings of a hypo-responsive period to aversive maternal cues prior to weaning. So it accords with both aspects of the rodent models, that there should be a stress response to low nurturance, but a hypo-responsive period to more aversive behavior. This is just a graphic sort of saying what a developmental salience model might look like, that there's some kind of gradient developmentally where the caregiver's unavailability is the primary threat, over early life, and then trauma as the threat to physical safety, threat of attack or injury becomes increasingly salient over later development. Of course, these are always both somewhat threatening to us. And we have no data at present that would calibrate what this line might look like, or what kind of developmental changes may mediate this sort of transfer. Regina Sullivan's data does suggest that after weaning in rodents, and that's sort of after the period of dependence on the caregiver is really sort of finished for the rodent, we might translate that, and she and Nim Tottenham have done some writing suggesting that perhaps after the period of attachment formation in humans, which would be, roughly 18 months to 2 years, that may be when this aversiveness becomes more salient to the infant. And the infant begins to respond both with the cortisol response and with the amygdala responses to a more abusive, aversive behavior by the caregiver. But we certainly need much more research to help us fill in the gaps here. So in closing, I'd just like to also comment on 3 prior findings that came from our earlier work on the family pathway study. So this was a previous longitudinal study of a cohort of socially at-risk families from infancy to age 30. The findings that I'm going to mention initially puzzled us, and they were also, I think, puzzling to the field at large. We had a lot of debates with colleagues about how to explain these findings. However, it now seems that they may also be consistent with the developmental salience model of threat. So the first important findings, also somewhat non-predicted, was when we looked at the 5 aspects of the ambience disrupted maternal interaction coding from 18 months videotapes. We, again, might have predicted that the mother's aversive behavior would be more likely to predict many of these later aspects of psychopathology. We had found that early aversive behavior, hostile intrusive behavior, was related to early conduct symptoms at school entry. I was reading about teachers, so we fully expected that to continue at age 19 when these assessments were made. And instead, we found that really only early maternal withdrawal, coded at 18 months, was predicting this range of impulsive self-damaging behaviors. So extent of borderline features, recurrent suicidality, substance abuse, conduct symptoms, eating disorders, antisocial personality disorder, and dissociation. So this was quite a surprise and not anticipated really in our prior theories. We then also found that, so we also collected extensive information on these young people's abuse experiences from infancy to age 19. And when we covaried the later abuse experiences, which also, and well-replicated findings, also predict borderline features and suicidality. So a robust effect there. However, regardless of later abuse experiences, early maternal withdrawal has a significant additive and independent effect in predicting borderline features and suicidality. So these are not assessing similar aspects of experience. They seem to be accessing quite distinct aspects of experience that contribute to an additive model of psychopathology. And it's really withdrawal measured at 18 months that's having this strong predictive effect, not withdrawal measured, say, at 8 years, when we also look at withdrawal measured concurrently in adolescence in interaction with the adolescent. So again, something's telling us that this early period is having an undue effect on later trajectories towards psychopathology. And then finally, we also found that at age 30, we were able to bring in a small group of these longitudinal participants. And we found that there was enlarged left amygdala volume in relation to, again, these behaviors seen on the 18-month video. So not only are they related to later psychopathology, they're related to later amygdala enlargement on the left side. Mother's disrupted communication, the infant's disorganized behavior, combination measure of both of those, but not childhood maltreatment. And instead, childhood maltreatment is registering on the right side of the amygdala. So several indicators here then that the early disengagement by the parent has very strong later effects on both psychopathology and possibly on brain volumes as seen at age 30. So we're almost out of time here. So just to say future directions, there's still very much more that we need to do to understand the complex mechanisms that are involved in the intergenerational adversity. Here we see that infant stress hormones and the postnatal caregiving environment may play an important role in human transmission, as it does in other species. We also know that gestational and epigenetic effects contribute in important ways to these pathways. So there'll be a lot of work ahead of us unraveling how prenatal and postnatal environments both interact to affect the infant's developing neurobiology. So very much just an exciting scientific challenge still to go. And I do hope that we'll have more to add to this dialogue as we look at our 15 months data and have more to report to you about that. So thank you again very much. Again, sorry to miss the meeting and being there in attendance with you and be able to discuss all these fascinating findings. But I look forward to the next WAIMH meeting.